Hey everyone, ready for another deep dive? Today we're taking a look at Imagine While Reasoning in Space. Multimodal Visualization of Thought.
This one is really interesting.
It definitely caught my eye.
It proposes a new way for AI to think, using not just words, but also pictures.
Oh wow, using images.
Yeah, it's about multimodal large language models, or MLLMs, that work with both text and images.
That makes sense. Images are such a natural part of how we think, right?
Exactly. And this research tackles a big limitation of how we've been using AI for reasoning.
You mean with chain of thought prompting, where the AI generates text to explain its reasoning?
Right, but imagine trying to solve a puzzle with only written instructions.
Yeah, that would be tough, especially for something visual.
Exactly. That's where spatial reasoning comes in. Things like navigating a maze or assembling furniture.
And traditional chain of thought just isn't good at that.
It struggles. And that's where this paper comes in. They introduce Multimodal Visualization of Thought, or MVOT.
MVOT. So instead of just text, these MLLMs create images to show their reasoning steps.
You got it. It's like watching an AI sketch out its thought process.
That's pretty amazing when you think about it.
It is. The researchers used a model called Chameleon 7B, trained with a method called token discrepancy loss.
Token discrepancy loss. I'm not familiar with that one.
Well, think about trying to describe a color with words.
Like there are so many shades of blue, right?
Exactly. Token discrepancy loss helps the AI match its understanding of words with its understanding of images.
So it's like making sure the AI doesn't draw a navy blue ocean when it's thinking about a sky blue.
You got it. It keeps the AI's thoughts, represented by tokens, aligned with the images. So the visualizations actually show the AI's reasoning.
Interesting. But how did they actually test this MVOT? Did they give it spatial puzzles to solve?
They did 3 different tasks, each more difficult than the last. First, a simple maze navigation, a classic spatial reasoning test.
Makes sense.
Then installing a printer in a simulated room, more real world.
Oh, that's a good one.
And finally, the frozen lake task, a real challenge.
Frozen lake, what's that?
It's a grid world environment. The AI has to reach a goal without falling through the ice. It's complex, with hidden patterns and dangers.
Sounds like they put MVOT through the ringer.
They did, and the results were impressive.
So how did it do? Did it solve the puzzles?
MVOT significantly outperformed traditional text-based reasoning, especially in the tougher tasks, like the frozen lake.
So it's like giving someone a map instead of just telling them directions.
Exactly. The visual aid makes a huge difference. But here's the thing. We talked about chain of thought earlier, right?
Yeah.
Well, it turns out MVOT and COT actually work really well together.
You mean instead of one replacing the other, they complement each other?
Exactly. When they combined predictions from MVOT and COT, they got near perfect accuracy, like having a map and someone explaining the route.
That's a great analogy. So it seems like MVOT is really promising, but how do we even know if those visualizations are good? Is there a way to judge the quality of AI-generated images?
Great question, and the researchers addressed that carefully. They used specific metrics to evaluate the visuals.
Oh, like what?
One was visualization accuracy, checking if the images actually match what the AI was trying to do.
Making sure the image shows forward movement if the AI is thinking about going forward.
Exactly. They also measured visualization pattern redundancy to see if the AI was adding unnecessary details.
So like making sure it sticks to the essentials.
Exactly. And that's where token discrepancy loss comes in again. It's key to high-quality visualizations.
So it's like the quality control manager, ensuring everything is on point.
You could say that. Without it, the images can get cluttered, which hurts the reasoning. But even with this technique, there are still limitations. Some visualizations, especially for the frozen lake, were a bit blurry or inconsistent.
So even AI artists have their off days.
Well, it's more about the limitations of the current technology, but that's the exciting part of research, acknowledging those limitations and striving for better results.
Absolutely. So how do we bridge the gap between how AI understands words and images? Like, do we need a translator for its thoughts?
That's a great point, and that's where embedding spaces come in. Imagine a map where similar words or images are clustered together.
So cat and kitten would be close, and ocean and sea, too.
Exactly. AI uses these spaces to understand relationships between concepts, both visual and textual. But here's the catch. Often these spaces come from different systems.
So like the AI is trying to speak 2 slightly different dialects.
Yes, and this misalignment can cause problems. So the researchers looked at token embeddings and visual embeddings within the model.
You mentioned token embeddings earlier, but remind me, what are they exactly?
Think of them as numerical representations of words. They capture the meaning of each word based on its context. And visual embeddings do the same for images, representing their visual features.
So each word and image has a unique code that the AI uses to understand it.
Exactly. And the researchers wanted to see how well these codes align. They compared the cosine similarity between these embeddings.
Cosine similarity. Refresh my memory on that one.
It measures how much two things overlap. Imagine two lists of words. Cosine similarity tells you how many words appear on both lists, so how similar they are.
Got it. And what did they find? Were the embeddings aligned, or was there a communication breakdown?
Surprisingly, there was quite a bit of misalignment. On average, only one token overlapped among the top 10 most similar tokens, and only about 20% in the top 50.
So it's like trying to have a conversation where only 1 in 10 words has the same meaning. That sounds like a recipe for disaster.
Exactly. And it shows why token discrepancy loss is so important. Without it, the visualizations would be like a game of telephone, where the message gets distorted along the way.
So token discrepancy loss keeps the AI's visual representations true to its thought process.
Precisely. It acts like quality control, ensuring the visual dictionary and textual dictionary are on the same page.
This token discrepancy loss sounds crucial for MVOT. But before we go further, let's consider the historical context. What research led to this breakthrough? What were the key ideas behind MVOT's development?
That's a great point. This research builds on a lot of work in cognitive science and artificial intelligence. The idea that humans use mental imagery to solve problems isn't new.
So they took that idea of thinking in pictures and made it real for AI.
Exactly. And it's only possible because of recent advancements in deep learning and MLLMs.
It's amazing how far we've come, from simple rule-based systems to these models that process images and generate their own visual representations. But wasn't there something similar before, using text-based visualizations?
You're probably thinking of visualization of thought, or VOT. It used text prompts to create text-based visualizations of the AI's reasoning.
So instead of drawing a picture, the AI would describe the picture using words.
Precisely. But VOT, while innovative, had its limitations. Relying solely on text meant it couldn't capture the richness of visual information. It's like trying to describe a complex scene using only words. You inevitably miss details.
It's like explaining the Mona Lisa using only adjectives.
Yeah.
You get the idea, but the true essence is lost.
Exactly. MVOT overcomes those limitations by generating actual images, allowing for a much more accurate representation.
So MVOT is like the HD version of VOT.
You could say that. And it's not just about the quality of the visuals. MVOT represents a fundamental shift in how we approach AI reasoning. We're incorporating visual thinking into the core of these models.
It's like we're moving towards a more human-like form of AI, where it can see and think about the world in a way that's more like us.
Oh.
But what about other approaches to combining text and vision for AI? Haven't there been other attempts to blend these two?
Absolutely. Researchers have been exploring this for a while. Some have focused on two-stage approaches. It means the process happens in two steps. First, the AI processes an image, extracting information like objects and scene descriptions. Then, this information is fed into a separate reasoning engine that uses text to solve the problem.
So the AI creates a text summary of the image, then uses that for reasoning.
Exactly. Others have explored using external tools like code interpreters and specialized vision models to enhance AI's reasoning.
So there's a lot of creativity in finding the best way to combine text and vision.
I agree. And MVOT takes a different approach. It uses the capabilities of MLLMs to directly generate visualizations without needing separate modules or tools.
So MVOT integrates visual thinking directly into the model.
Precisely. And this direct approach has advantages. It simplifies the architecture and makes the reasoning process more interpretable.
Interpretable, meaning?
Meaning we can understand how the AI reaches its conclusions. By seeing the visualizations, we can identify potential biases or flaws in its logic.
That's crucial. As AI becomes more integrated into our lives, trust in its decisions is paramount. And trust is built on understanding.
Absolutely, and that's why MVOT is so exciting. It helps make AI reasoning more transparent and accountable.
This has been a fascinating look into the technical details of MVOT, but I'm curious about the historical context. What research paved the way for this breakthrough? What were the key ideas that led to MVOT's development?
That's a great point. This research builds on a rich history of work in both cognitive science and artificial intelligence. The idea that humans use mental imagery to solve problems is not new. Philosophers and psychologists have been exploring this concept for centuries.
So this paper is taking that age-old idea of thinking in pictures
Yeah.
and making it a reality for AI.
Exactly. And it's only possible because of the recent advancements in deep learning and the development of these powerful multimodal large language models.
It's incredible to think how far we've come, from simple rule-based AI systems to these complex models that can process images and even generate their own visual representations. But didn't someone try something similar before, using text-based visualizations?
You're probably thinking of visualization of thought, or VOT. It used text prompts to get the AI to create text-based visualizations as a way to represent its reasoning process.
So instead of drawing a picture, the AI would describe the picture using words.
Precisely. But while innovative, VRT had its limitations. Relying solely on text meant it couldn't capture the richness and nuance of visual information. Imagine trying to describe a complex scene using only words you'd inevitably miss crucial
It's
details.
like trying to explain the Mona Lisa using only adjectives. You'd get the general idea, but the true essence would be lost.
Exactly. MVOT overcomes those limitations by generating actual images, allowing for a much more accurate and detailed representation of the AI's reasoning process.
So MVOT is like the HD version of VOT.
You could say that. And it's not just about the quality of the visuals. MVOT represents a fundamental shift in how we approach AI reasoning, incorporating visual thinking into the core of these models.
It's like we're moving towards a more human-like form of artificial intelligence, where AI can see and think about the world in a way that's more aligned with our own cognitive processes. But I'm curious, what about other approaches to combining text and vision for AI reasoning? Haven't there been other attempts to blend these two modalities?
Absolutely. Researchers have been exploring this area for a while now. Some have focused on two-stage approaches.
Two-stage approaches.
It means the process is broken down into two steps. First, the AI processes the image and extracts information from it, like identifying objects or describing the scene. Then, this extracted information is fed into a separate reasoning engine that uses text to solve the problem.
So it's like the AI first creates a textual summary of the image and then uses that summary to reason about the situation.
Exactly. Others have explored using external tools like code interpreters and specialized vision models to enhance AI reasoning.
So there's a lot of creative energy flowing into this field, with everyone trying to find the best way to combine text and vision.
I agree. And MVOT fits into this landscape by taking a different approach. It leverages the innate capabilities of MLLMs to generate visualizations directly without relying on separate modules or external tools.
So it's like MVOT is a more streamlined approach, integrating visual thinking directly into the heart of the model.
Precisely. And this direct approach has some interesting advantages. Not only does it simplify the architecture, but it also enhances the interpretability of the reasoning process.
Interpretability, what do you mean by that?
It means we can understand how the AI is arriving at its conclusions. By seeing the visualizations, we get a window into the AI's thought process, making it easier to identify potential biases or flaws in its logic.
That's a crucial point. As AI becomes more integrated into our lives, it's essential that we can trust its decisions. And trust is built on understanding.
Absolutely. And that's why MVOT is so exciting. It offers a powerful tool for making AI reasoning more transparent and accountable.
This has been a truly eye-opening exploration of MVOT and its potential. But I can't help but wonder, what's next for this technology? Where do we go from here?
That's a great question, and it leads us perfectly into our Novel Notions segment, where we'll explore some thought-provoking ideas about the future of MVOT.
Okay, I'm intrigued. Hit me with your wildest idea. What's the next frontier in visualizing AI thought processes?
What if we go beyond static images and use MVOT to generate videos of an AI's thought process? Imagine watching a movie of the AI reasoning through a complex spatial problem.
Whoa, hold on. We're talking about AI making its own thought process movies. That sounds straight out of science fiction, but how would that even work?
It's definitely a bold idea, but imagine combining MVOT with the power of video generation world models. These models are already making waves in fields like robotics, allowing AI agents to simulate and predict real-world dynamics.
So we'd be merging the ability to visualize reasoning with the ability to simulate complex scenarios. That sounds incredibly powerful, but I have to admit, I'm struggling to wrap my head around the practical implications. Walk me through a potential scenario where this video MVOT could be used.
Imagine a team of researchers trying to debug a complex AI system designed to control a fleet of delivery drones. They're stumped by a recurring error that causes the drones to make illogical decisions in certain scenarios. Now, instead of just sifting through lines of code and data logs, they can watch a video generated by the AI showing its step-by-step thought process as it navigates the simulated environment.
Okay, I'm starting to see the potential here. It's like having a video replay of the AI's mind, allowing the researchers to pinpoint the exact moment where its reasoning goes astray.
Exactly. They could literally see the flaw in the AI's logic unfold before their eyes. But it goes beyond just debugging. This technology could revolutionize how we educate people about AI. Imagine using these videos to explain complex AI concepts to students or policymakers, making this often intimidating field more accessible to a wider audience.
It's like giving everyone the ability to read an AI's mind, fostering greater understanding and trust. But as we wrap up part one of our deep dives, we have to acknowledge that this is all still very much in the realm of novel notions.
Precisely. This is about exploring possibilities and pushing the boundaries of what we think is possible. But who knows, maybe one day these novel notions will become reality, shaping the future of AI in ways we can only imagine.
And speaking of shaping the future, we'll be back in part two to delve even deeper into the exciting world of multimodal spatial reasoning. Stay tuned.
See you then. Welcome back. We've been exploring MVOT, letting AI think with both text and images. Now let's zoom out and look at the broader research scene in multimodal spatial reasoning.
So we're seeing where MVOT fits in the big picture. I'm in.
Exactly. It's a hot area right now. Researchers are working on teaching AI to understand spatial relationships, movement, and how things interact in an environment.
It's funny how something that's so natural for us, like knowing what's over or under, is tough for AI.
I know, right? But it's crucial to figure out so many real-world applications needs spatial reasoning. Self-driving cars, robots in warehouses. AI needs to grasp space to work safely and effectively.
It's like we're giving AI that spatial awareness we use every day, often without even thinking.
Precisely. And to test this, there are all these new benchmarks and data sets popping up.
Benchmarks and data sets. What are those?
Think of them as tests to assess AI's spatial IQ. They cover all sorts of tasks, from answering questions about images to things like navigating, manipulating objects, even understanding social interactions with a spatial aspect.
Like a spatial reasoning boot camp for AI.
Yeah, exactly.
Cool.
A lot of the work is focused on understanding how actions change things spatially. It's not just about knowing where objects are, but how actions transform the whole environment.
Sounds pretty complex. Got an example?
Sure. Think about an AI arranging furniture in a room. It needs to know that moving a chair not only changes the chair's position, but also maybe blocks a path or opens up new spots for other stuff.
It's like a strategic Tetris game. Every move changes the whole board.
Perfect analogy. So how do researchers teach AI about these dynamic spatial relationships? Well, there are a few ways. One is using 3D visuals during training.
Giving the AI depth perception, like us.
Exactly. That helps them understand spatial relationships in a more human-like way. Another method uses something called scene graphs.
Scene graphs.
Imagine a blueprint of the environment. Scene graphs show the relationships between objects in a scene, like the lamp is on the table is next to the couch.
So it's giving AI a map of how everything is connected.
Right, and how those connections change as things move or interact. So with all this research going on, how does MVOT fit in? What's its special sauce?
Yeah, that's a good question.
Well, MVOT brings something unique to the table: interpretability and transparency. Many approaches are focused on making AI better at spatial tasks, but MVOT helps us understand why AI makes certain choices.
So we're not just happy with the right answer. We want to know how it got there.
Exactly. And this focus on interpretability is huge for building trust in AI. Think about it. What if we could rely on AI and understand its reasoning? We could easily spot biases, mistakes, or unintended consequences.
It would be like having an AI that can explain itself, making it accountable for its actions.
Right on. And MVOT visualizes spatial reasoning in a way we humans get. It opens doors to better collaboration between us and AI.
Collaboration. How so?
Imagine architects working with AI to design a building. They could see the AI's spatial reasoning with MVOT, get insights into its design choices, spot potential flaws, ultimately create a better building by working together.
That's a pretty cool future. It's like having an AI teammate, not just a tool. But let's be real, we're still in the early days. What challenges and limitations still need to be figured out?
One big one is figuring out how to represent spatial info in a way AI can understand and reason with. We humans just get spatial relationships, but teaching that to AI is tough.
Yeah, it's like explaining depth to someone who's only ever seen 2D.
Exactly. It's hard to break down something so basic to our perception. And it gets even more complex when you think about all the different spatial tasks AI could face in real life.
So it's not about solving one puzzle, it's about giving AI the tools to tackle any spatial problem.
You got it. It's about generalizability and adaptability. That's driving a lot of research right now. 3D info, scene graphs, new algorithms, all to create better ways to represent spatial knowledge.
It's a really dynamic field, isn't it?
It is. And MVOT is a powerful tool within all this. It lets us see how AI approaches spatial problems, what kind of mental models it builds, and where it might struggle.
We're peeking under the hood of AI spatial intelligence, getting valuable insights. And that's crucial for building trust, especially as AI becomes a bigger part of our lives.
Absolutely. But of course, with great power comes great responsibility, right? We need to make sure AI spatial intelligence develops safely, ethically, and in a way that benefits everyone.
Good point. It's a reminder that AI isn't just about algorithms, it's about the relationship between humans and machines.
Couldn't agree more. But enough serious talk, ready for another dose of novel notions.
Always. What mind-blowing idea do you have for us this time?
What if, instead of just visualizing AI's thought process, we could manipulate it through a spatial interface? Like a virtual reality environment where researchers can interact with the AI's spatial representations directly.
Hold on, we're talking about going into the matrix of an AI's mind and rearranging its spatial furniture. That's a bit wild, even scary.
It is a wild idea. But picture this. MVOT combined with advanced VR. The AI creates its visualizations in the VR world, and the human, using VR controllers, can interact with them.
So we'd be like virtual architects inside the AI's mind, shaping its understanding of space.
Precisely. We could guide its reasoning, point out things, highlight obstacles, suggest paths, like teaching a child to navigate, but inside the AI's mind.
That's crazy. But wouldn't we need to understand how AI represents spatial info to do that? Like, learn its language of space.
Exactly. That's the challenge and the opportunity. To build that spatial interface, we'd need huge breakthroughs in understanding both human cognition and AI.
It's like creating a Rosetta Stone for AI spatial intelligence.
Right. Not just understanding its thoughts, but shaping them. And the applications go beyond research. Think about education, art, therapy.
Students learning by walking through AI models, artists collaborating with AI, therapists helping patients overcome spatial anxieties in virtual spaces.
Exactly, a whole new dimension of human-AI interaction. But as with any powerful tool, we have to be careful. Safeguards are needed to prevent misuse, manipulation, or harm.
It all comes back to responsible development, ensuring these advancements are ethical and truly benefit humanity.
Couldn't agree more. But for now, let's enjoy this novel notion. It pushes our imagination and gets us thinking creatively about the future of AI spatial intelligence.
Who knows, maybe one day we'll be exploring AI minds in VR, unlocking new levels of understanding and collaboration. But that's a conversation for another time. Join us in part 3 as we wrap up this deep dive into MVOT and its long-term implications for AI's future. And we're back for the final part of our deep dives into MVAT. We've covered a lot, from the nitty-gritty of token discrepancy loss to the big picture of multimodal spatial reasoning. We even explored those novel notions, those future possibilities.
Yeah, it's been quite a journey.
It really has. So before we wrap up, I'd love to hear your thoughts on the long-term implications of this research. How do you see MVOT and multimodal spatial reasoning shaping the future of AI?
It's a great question. I think we're seeing a real shift in how we think about AI reasoning. By bringing in visual thinking, we're moving toward a more intuitive, human-like AI.
It's like we're teaching AI to see the world more like we do.
Exactly. And that has huge implications for so many fields.
I can only imagine.
Imagine AI that can not only do complex tasks, but also explain its reasoning in a way we understand. It'd be like having a true AI partner, one we can trust and collaborate with.
That trust is so important as AI becomes more and more a part of our lives in healthcare, finance, everywhere.
Right. If we can understand how AI makes decisions, we can make sure they're safe, fair, ethical, And MVOT is a powerful tool for that.
It really is. It gives us a way to see inside that black box of AI, to understand the why behind its actions.
And this research also shows how important collaboration between different fields is.
Yeah, MVOT draws from cognitive science, computer vision, natural language processing.
Exactly. To push AI forward, we need experts from all these areas working together, sharing their knowledge.
It's like we're building a bridge between the human mind and the artificial mind.
That's a great way to put it. And as we move into this new era of AI, it's clear that there will be incredible opportunities and really complex challenges.
An adventure, for sure.
It is. But I think with curiosity, collaboration, and a commitment to doing things the right way, we can navigate those challenges and unlock the true potential of AI.
Well said. I think that's a perfect note to end on. Thank you so much for joining us on this deep dive into MVOT. It's a rapidly evolving field, and we can't wait to see what the future holds.
It's been a pleasure being here.
To all our listeners out there, keep exploring, keep asking questions, keep imagining. The future of AI is a story we're all writing together.
Yeah.